Yeah, hi everybody. I'm Dr. Mahabub Basha, Professor and Head Department of CSE, Madanpalli Institute of Technology and Science, Madanpalli. As part of initiation taken by our institute, I want to deliver lectures on GATE topics. There are so many topics which are asked as part of GATE examination, but mainly when you take, there are several groups in that. There is one group which is data structures group, data structures and programming. So because this data structures and programming group has a lot of weightage, so I have seen the last 5 to 6 years question papers. On average, there are seven questions, and maximum in some exam there are 14 questions have come. So the weightage is more here. And in this, when you take the programming alone, I'm trying to cover the topics in 2020. Here there are three questions only on C. 2019, there are nearly seven questions on C. We'll see all those questions. 2018, nearly five questions. So this is the weightage of data structures and programming, because there are huge topics. I want to start with programming topic, and in programming topic, C is the important the language. I think it is the only language used here, and most of the questions are out of C, based out of C. So I'll be concentrating on C. But in C, I want to cover some topics. I am not going to cover all topics here. I'm going to cover the topics based on the GATE syllabus. So the important topics are mainly, I think, it is functions is one topic. Under functions, we'll also see recursion. And when you take one more, storage classes, so they're all linked. Several questions are combined with functions, recursion, and storage classes, because storage classes are also based on the functions. So in this lecture, I want to mainly concentrate on function, recursion, and storage classes. Next, I'll give pointers, because pointers is very one more very important topic, and most of the questions appear on that. And it is the topics which is wrongly understood and wrongly taught. So I'm going to concentrate on pointers. Now, in this particular lecture, I want to concentrate on functions, recursion, storage classes. So when you take, first I'll start it with functions. So functions is the unit of a program which will be containing a part of the program to take care of a particular task of the main problem. So normally to divide the complexity, to meet the complexity easily, the problem is divided into smaller tasks, and every task is done by a particular function. So function is an independent entity. It cannot be executed independently. It must be executed as part of main program, but it is an independent entity to perform a specific subtask of the main program. So this is to take care of the complexity. Now, when you take the functions, the functions has two things we have to cover here in functions. One is actually one thing, important thing to cover, because most of the other things are basic things. So I'm going to cover here passing of parameters, because based on that there are several questions appearing. So passing of parameters is an important topic. So I'm going to cover passing of parameters. And you know that passing of parameters can be done in two ways in C. One is by value, another is by address. So these are the two ways we can pass the parameters to the functions. So when you take pass by value, so suppose if I take, I'll also be using some editor to prove that whatever approach we are following with respect to a GATE question is correct, because we have to ensure that the results are correct. So I'll also be using some compiler to execute some programs. Here in when you take some function, so I have a function like void test. I have function void test and x is the parameter. Here I'm taking main function, and main is the function which calls this, and the test is called from here. With the there will be there is a local variable here, a suppose 20. I'm calling test from here. So this is actually a pass by value. In pass by value, what happens here? There will be a variable, local variable, local to main, and it will occupy some memory area. And the value there is 20. And here when we call this function, a copy of the actual parameter, this is actual parameter, is maintained in the form of formal parameter. So x is created here as a copy of a. So if I'm doing some changes to x here, so I'm doing adding 10 to x, this will change. Even though this is actually a representative of this a, but it is not the original variable, it is copy. So the changes made to the formal parameter, which is getting the value in the form of pass by value. So the changes made to the formal parameter will not be reflected in actual parameter. So that is the important point to note here when it is passed by value. So because we are working on the copy, not on the original variable itself. Now when you take pass by address, so when you take pass by address, so I'm taking pass by address. So pass by address. So in this case, pass by address, I'm taking one more function called fun. And here, when you pass by address, the formal parameter, whatever we pass, is actually the pointer. So there will be a pointer here, which will be getting the address of actual parameter. So there is a pointer p here, which is this is a formal parameter. So in pass by address, the formal parameter must be pointer, because we have to pass the address, and there it must take the address. The only variable would take which take address is the pointer. So I have main here. So when you take main, main is the function here. Main, if I take main, there is a variable a here, int a equals 20, like what I have used earlier. Now I'll be calling this function. So this is one function. So I'll be calling the function by passing address of a. So the important thing with pass by address is when I call like this will go into this. When it will go into this, the statement will be like this. Int asterisk statement can be considered like this. So what I am doing is I'm declaring a pointer, and that pointer is pointing to a. So there is this is how what happens when we pass address as parameter to function, and this is passed by address. So when you take a is a variable which will be having some memory, and the value there is 20, and I'm taking one more variable pointer p here. And the important thing is, suppose if this has address 1000, so 1000 is moved into this pointer, and 1000 the p is pointing to a. So this is actual variable, original variable. This is the formal parameter. Even though we are not working on the original variable directly, indirectly we are working on the original variable itself, because we are using the pointer. So we are not working on the copy in pass by address. We are not working on the copy. We are working on the original variable itself, of course, indirectly through pointer. So now suppose if I do some changes here, like this. So I'm adding now when I say asterisk p, or to be much simple, instead of this, I'll write simply asterisk p equals to 30. So when we use dereferencing operator asterisk here, asterisk P actually what it says is whatever present in P, take that and go to that location and access that variable. So we are going to modify the original variable itself, but of course indirectly with the pointer. So even though we are doing it in function, but because we are using pointer, we are working on the original variable itself directly. So changes made to the function, changes made to the formal parameter within the function will be reflected on the actual parameter. So this is one important concept. So based on how we pass and what we do in the function, there will be changes on the original variable, and there will be several questions on this. So that is the reason why I gave this one simple concept on pointers. Sorry, on this functions which is passing parameters. So the next topic which we may require before we see some questions on functions is recursion. So when you take the recursion, recursion is the technique in which a function calls itself. So if I have some function test, if I have a function test, if my function is calling itself, then it is recursion. There is one more kind of recursion. There is function 1 and there is function 2. And when the two functions are calling each other, then it is also a recursion. So function 2 calls function 1 and function 1 calls function 2. So this is also a kind of recursion. So recursion is the process in which a function calls itself. Mainly we see this kind of recursion where a function calling itself, and even the other cases where two functions are present which are calling each other, that also come under recursion. Now, when you take the recursion, the important thing recursion is because the function is calling itself, there is a danger of this entering into infinite loop. So to avoid infinite execution, recursion must satisfy two criteria. So there must be two criteria which must be satisfied. One is the base criteria, another is update criteria. So suppose if you have a function here, when you have some function within in a program, there is a function and which is actually calling itself. So here generally when there is a recursion, there will be some variables present. So I'm taking some variable here. So int n. Here the base criteria, what it says is at some stage, for some condition, the function should not call itself. Function should not be calling further. So this is the base criteria. So if n is not equals to 0, I'll call function. So here the base criteria here is this one. So there must be some condition within the function, recursive function, where when that particular function is satisfied, only the function should be called. Otherwise, it should not be called further. So that is base criteria. If there is no base criteria present, which is even present, sometimes it may be wrongly built. When there is no base criteria properly built, there is a possibility of the function entering into the infinite execution, which is undesirable property in programming. So this is the base criteria. The base criteria is when n is 0, then the function will not be further called. And the second one is each time the function is called. Here we are calling the function. Each time the function is called, we should reach nearer to the base criteria. Here we'll assume that n is a positive number. So each time we call the function further, so we are reducing it by 1. So when we reduce it by 1, we are reaching nearer to the base criteria. So if these two things are not there, even if I have base criteria and if I say n plus 1, then it will never reach. It will enter into infinite loop and it is undesirable property. So these two conditions must be satisfied. There are some questions based on this. So when you have a recursion is very simple, simple technique. but it may lead to infinite execution. Some complex problems can be solved easily with recursion, but if you take proper care in the form of base and update criteria, then recursion will produce always the required result in a simple way. So recursion solves so many complex things in a easy way. But of course, it has got its own disadvantages. That is not the topic here. The important thing which we should concentrate here is base and update criteria. So this is one more concept which I want to give before we solve some problems on this particular topic. The next one I am going to give is storage classes. This is very important topic for not only the GATE point of view, for even the students who are preparing for any hackathons, or even if they are preparing for interviews, the storage classes, it's an important thing. Now, before we see what is storage class and what are the properties it will be impacting, what are the properties of variable it is impacting, we should know the memory diagram, because it clarifies so many things. So the memory diagram for C program. So this is actually required before we proceed with storage classes. So I want to give the memory diagram of a program. So when you take a C program is C, or not only C program, any program you take, they will be occupying memory area. So the memory is divided, that area given to the program is divided into several parts. First part is actually called as text or code. The program what we write is this is code, the object code or executable code, text or code. That is the first part. The second part is data part. This is the data part, and this is divided into two parts. This is divided into two things. One is initialized data, and another is uninitialized. And this is the first part is this one. So this is the first part. Is second part, data part, which is having two things further, and the next one is heap. This is the memory part. There are actually four parts: text, data, heap, and stock. And I'll give you what is what, because it is very important to solve several questions. This is code part, and it is read-only part. We cannot do anything. Now, data part is actually, in C program, we have global and static variables. Global and static variables. So this global and static variables, they get space here. So the important thing is they get space before the program begins. So during the loading of the program, so after we compile the program, link the program to the library, the program, when it is loaded, all global and static variable will get space. That means before the execution of the program begins, the global and static variable will be there in memory, and they will be there in memory till the end of the execution of the program. That is the very important point to note, because several questions are based on this. So global and static variable get space in data part of the program before the execution of the program, and they will be there till the end of the execution of the program. Now, when you take the static variables, they are divided into two: local or local static variable and global static variable. But whatever it is, static variable is occupying data. And of course, the scope is different. I'll come to the scope little later when we discuss about storage classes. Whatever may be the scope of the static variable, the global and static variable will be there in memory before the execution of the program begins, and they will be there till end of the execution. And so that is one very important thing. So they will be there live till end of execution, even their scope is different. So data part holds just global and static variables, and it is divided into two initialize. Suppose if you know that global variable is the one which is declared outside the function. So if I declare int a 25, so I'm explicitly initializing this variable to some value because it is explicitly initialized, it goes into this. Now I have a static variable, maybe local or global. We'll see the difference later. Now I have a static variable int x equals to 5. I'm explicitly initializing, then also it will go to this. So all global and static variables, they go into initialized part if they are explicitly initialized. Suppose if I take one more global variable int b, if I don't initialize it. Similarly, I'm taking one more static variable, static int y. I have not initialized. So all initialized variables are collected here. All uninitialized variables are collected and kept here. Uninitialized global and static variables are collected and kept. Why this division made is all uninitialized variables can be quickly initialized with zeros. So if you don't explicitly initialize global and static variable, they will get automatically zero. And because the initialization has to happen, all uninitialized variables are grouped at one place, and attested the entire area is filled with zeros. So all the variables become zero. So this is the important thing. So the important point to note here is the starting and global variables, if they are not explicitly initialized, they are initialized to zero. How it is done, I have given here. They are grouped separately, and at a time they will be initialized. It is quicker way of doing. Finally, once uninitialized variables are initialized, then there is only one part, data part, as far as the program is concerned, and that data part contains static and global variables. Full those variables will be there from beginning of execution of the program to the end of the execution of the program. This 2 points we have to note. The variables, these variables will be there from beginning to end of the program. Second thing, they are initialized to zero. Now, when you take stock is another important. Stock and heap are dynamic areas. Why I'm saying dynamic means during the execution of the program, they are growing and shrinking. Now, if you take this data part is fixed. Means once the program execution begins, I cannot do anything there. Means I cannot add a variable there or remove a variable there, because they will be created before the execution of the program. So that's why they are all static. Means the area is static. The values we can modify. The area is fixed. Whereas heap and stock, they will be growing and shrinking. They are dynamic areas. And heap is not that much important here as far as our concept is concerned. Heap, you can say it is for dynamic memory allocation, and it is only for pointers. So if I take heap, it is part of dynamic memory allocation, and it is only for pointers. Only pointers get the memory from that. And stock is a different thing. And stock here, mainly there are so many things that are kept in stock, but when you take stock holds automatic variables. It holds automatic variables. Of course, there are other things that are stored in stock, like parameters passed to the program. They are stored there, and even if you take the return addresses, are also stored there. But we are not much bothered about return addresses, because our aim is different. So parameters, they are like automatic variables. They will be there in stock. So when a function is called, stock creates automatic variables and parameters, so stock grows. When function execution is over, the automatic variables will be removed and parameters will be removed from memory, from stock strings. So based on the calling of the function, stock is growing and shrinking. That's why it is dynamic. Heap is also a dynamic because we can explicitly take memory area from heap allot to the pointer. So stock holds automatic variables, and the important thing is this automatic variables are will not be permanently there. Permanent here means the duration of the program. They will not be there in the entire duration of the program. They will be there in the duration of the function. I'll come back to that later when we discuss about storage classes. So stack holds automatic variables, and automatic variables will not be staying from beginning to end of the program. They will be staying temporarily in memory. When they stay, we'll see that as part of the storage classes. So these are the memory areas. So stock is a temporary area and it is dynamic area. It is growing and shrinking based on the calling of the function. Data is a heap. Don't worry much about heap because there will not be any theoretical questions on heap. Only dynamic memory allocation. We need not bother about how heap works for allocating dynamic memory. Just remember that there is a heap for dynamic memory allocation. Otherwise, you need not know anything about heap. Stock is very important thing because it holds automatic variables and it grows and shrinks uh, during the execution of the programs. That's why it is dynamic. Now, data is fixed because once the program execution begins, it will be there fixed in the sense the size is fixed, the values you can always change it. And it holds static and global variables and they will be there from beginning to end. And if we don't explicitly initialize, they are initialized to 0. So this is the concept which we should know with respect to this. Next, we'll see the storage classes. When you take the storage classes will give some three important properties of the variables. One is scope, second one is the lifetime, third one is default initial value. Third one is default initial value. Now, when you take scope, see, scope is the area of the program, part of the program where a variable is valid. It is some area of the program. That area, how it is decided, we'll see. Area of the program where variable is available. Because sometimes even the variable is there, but in memory it will not be available because its scope is it is out of scope. So where variable is available or accessible, that is scope. When you take scope, I'll come to that scope. Lifetime is the duration in which the variable is there in memory. This is very important thing. Like I told you, static and global variables, the lifetime is the entire program. The automatic variables, the lifetime is only the function in which they are declared. I'll come back to that again. So default initial value is the one which will be given automatically to the variables which are not initialized. I have told you for, already that static and global variables will get 0 as initial value automatically if we don't explicitly do it. So default initial value will come into picture if we don't explicitly, suppose if you are not explicitly giving a value, explicitly initializing. So if you are not explicitly initializing, then the case of default initial value will come. If you are explicitly initializing a variable, suppose if I take a variable A, I'm not explicitly initializing. If I take variable B, 10, here I am explicitly initializing. Now this will get automatically based on what type of storage class the variable carries. So that is the thing. And now we'll see the different storage classes. When you take the different storage classes, the important storage classes are auto storage class, then global storage class, then static storage class, then register storage class. So register storage class. Register, I think very few questions, but still I'll give you what is register storage class. When you take the auto storage class, if a variable is declared inside the function, suppose if I have a function int function test. So now I'm giving about the auto storage class. If a variable is declared inside the function without any related with storage classes. The keywords related with storage classes are auto is keyword related with storage classes, static, register, external. So these are not storage classes, they are keywords related with storage classes, and these are the storage classes. So if I declare a variable inside a function without any keyword or with a keyword auto, A and B are automatic variables and they are local to function. If I declare a variable with static int x, now this is not local variable. This is automatic variable. This is automatic variable. This is not automatic variable. It is static variable. Even if I say extern int y, so this is not automatic variable. So if a variable is declared inside the function and with a keyword auto or without any keyword related with storage classes, then that variable gets auto storage class. So that is the important thing. Now, when you take the auto storage class, a variable is having auto storage class. Then in this case, A, B are having auto storage class, and X1, X and Y, they have different storage classes. Now, when you take the automatic variable, the important thing is the automatic variable will have, we have to see scope, lifetime, because any storage class will define all these things. So default value, default initial value. So when you take all these variables, they will have any storage class will define these things, and scope is actually the automatic variable will get the scope of the function, means that they are valid only within the function. They get function scope. Strictly speaking, they get a block scope. They get a block scope. Suppose if I take void test. Here I am having. Now I'll take a function. Now block in C is anything which is surrounded by opening and closing flower bracket is a block. This is a block in C. Function is a block, and suddenly in between I may have a block by keeping this just these things. So now when I take int A, this is a variable which gets scope of this area, entire area, it is available. Now if I take int B, because I am declaring inside this block, this will get only this scope. This is block scope. So within this, anything is a block which is surrounded by this. It may not necessarily a function block or loop block or if block or switch block. Even simply I can write a block by opening and closing brackets in C. That's how C works. So this is a block, and B gets scope of this block only, and A gets the scope of this. Now the very important thing is, now I can take int X here. X and B get same scope, which is this block, means they are available or valid only in this block. Now this int A is available in the entire function. So because the scope is from beginning of the function to the end of the function. Here they get the block scope. They get the scope from this bracket to this bracket. Though the very important thing is, within the same scope, you cannot have two variables with same names. That is very important point to note. So within the same scope, so I have whatever may be the scope, I'm taking a block scope. I'm taking variable A1. I cannot take another variable A1 here because they are there in the same scope. Now A is there, I can declare int A here. Now the scope of this variable is different, the scope of this variable is different. So now I can have two variables with same name as long as those variables are having different scope. If two variables are having same scope, I cannot have the same name. That is one point to note. Now, when I take this A, this is one point to note here is, which is useful when you solve some questions is, now when you take A scope is from here to here. And this A scope, so I'll take, I'll remove here and scope is from here to here. Now the important thing is the scope of inside the A of inside the block will fall under the scope of A outside the block, but within the scope of this area, this will be hidden. This A will be hidden. Because this is local scope, local to this block. So always local variable to the block is having more weightage than the other variables outside the block. So even though this A is available within the scope of this, but because of this A will be hidden within the scope of the second A. This is second A, this will be hidden. That's how the programming works in C. So this is one important thing. So when you take the scope of automatic variables, they have block scope because uh, uh, when I say block, anything which is opening and closing brackets is a block. Even function is a block, loop is a block, if is a block, switch is a block. Even without all those things, if I simply write opening and closing bracket like what I have given here, it is like what I have given here, it is also a block. So the automatic variables will be having block scope, means the block in which they are declared, they are available only there. Suppose the important point to note is within the same scope, two variables cannot have same name. And if the scope is different, two variable will have same name. By chance, if two variable scope is overlapping, then local variable will be given preference. Local to the block variable will be given preference, means will be available by hiding the variable which is outside declared outside that block. So this is one important thing. And when you take default initial value of local variable is garbage. But some editors may automatically fill it, but theoretically, mostly it is garbage. Means garbage is the one which is unknown. So some value will be assigned which is unknown. Unknown is the one which is useless to us. That's why it is garbage. So the default initial value is unknown. Unknown variable, unknown value is not useful to us. So when something is not useful, it is a garbage. So it is a garbage value. And the lifetime of the automatic variable is during the execution of the function. So forget about this block now. Okay, I'll assume that there is no block here. Okay, I'll take for better understanding, I'll give the lifetime again. So I have a function test. In, so the important thing is when I call from main, I'm inside main. So I'm inside main. I call test from main. So when I call test from main, when function is called, this is automatic variable that gets space in stock. So take stock like this. So they get space in stock. all automatic variables. So all automatic variables get scope in space in stack when the function is uh, under execution. So I'm calling the function. Now the function execution begins. Just before the execution of the function begins, A gets memory in stack. And the execution continues. Once execution is finished, then this is removed from memory. This is removed from memory. Then again test is called. Again A is created, maybe in the same place or different place. It maybe there may be some other things present. A may be created with uh, again separately. This is no more available. This A is no more available. A is freshly created. When I call second time, it is freshly created. When it is created, it is initialized. Then when execution is finished, it is also removed. So the important point to note here is the lifetime of automatic variable is the duration in which a function is under execution. Before the function execution begins, just before the function execution begins, the variable gets space in stack. When the execution of the function is over, it is removed from stack. So each time we call the function, this process happens. Each time we call the function, the variable will be created freshly. So whatever has happened earlier, it is no way impacting the current creation of the variable. So that earlier creation, they are no more present. Values, they will be erased. It is fresh creation. Whereas static variables, they will be there in memory. Whatever values they are there, they remain there because they will be live during the entire course of execution. So that is the lifetime of automatic variables. This concept is very important because based on this concept, there are some questions present. So what is the time that has taken? Because next, we'll see the global variables. Before we see the static variables, I want to give global variables. Now, the important thing with the global variables are their important point to note is they are declared outside the function. The global variables are declared the outside the function. They generally will have file scope because when you take a program is not necessarily one .c file. It may be collection of several .c files. So if I variable, if I have main function, so you know that C program is collection of functions. There is one more function here, function one. So normally the global variables are declared outside the functions. So if I take m is a global variable because it is declared outside the function. So a variable becomes a global variable when you declare it without any keyword outside the function. So when you take a global variable, the scope of the global variable is file scope. That means suppose if I have written this program in in a file called 1.c, 1.c, there is one more program which I may have as part of one more file which I may have as part of the same program 2.c. There also there may be several functions present, so there may be some function. Now there is int n. N is global to and the scope is this file. M is global and scope is this file. So the global variables will have a file scope, and that file scope is means they will be available in the entire file, not in the other file. If you want to have this global variable available in other files, we can do it. That is with the help of extend keyword. Now, right now, the just remember that global variables will have file scope. So they are declared outside of function in a file, and they will be available in the entire file. And a program may have multiple files, and every file will have some global variables, and the global variables are available only in that file. So that's why they are called as they have a file scope. So they are said to have a file scope because they are available only in that file where they are declared. And as I gave you, these variables will be created. So this is scope. When you take the lifetime, the variables are created in whichever file they are there. they'll be at one place and they are there in data area, data part of the program. So because they are that data part is created in before execution of the program, so the lifetime is the entire program. So entire duration of the program, they will be there in memory. So they'll be live in memory. So that is the lifetime of entire duration of the program. They will be there in memory. Entire lifetime of the program, they will be there. So that is lifetime. And default value, as I told you already, global variables will get by default 0 value. So this is one more point I had to tell about global variables. And one more point, like I told you, they have scope of the file. If you want to extend the scope, this is, I'll also cover that because it will complete the global variables. So it will complete the global variables. Now I'll take the same thing. Now this I want to make it available here. If I want to, actually this is having file scope, it is available only in this file. I want to make it available here. If I want to make it available here, what you have to do is you have to say extern int m. So when I write extern int m in 2.c, what it says is m is declared elsewhere and use that m here. So this is actually extension of scope of global variable. So I'm extending the scope of the global variable across the files. That is one use of extern keyword. Now suppose if I don't use extern keyword and write int m here, this m is different. So this m will have its own memory and this m will have its own memory. So if I use extern, okay. So if I use extern, what happens is m is having memory here. Now this extern int m will not create any memory. So what it says to the compiler that m is declared somewhere. It has memory. Use that m here. The same m is used. Now if I, as I told you, if I don't use extern here, then what happens is this is not shared here. Its scope is not extended. It is not shared. Another variable m is created within this file scope because the scope is different. So we can have same name. So now if I don't use keyword extern, memory is allotted, another variable is created. So extern, if I use, then no memory is allotted. So that's why extern is treated as a declaration of a variable where no memory is allotted. Extern is treated as a declaration. So variable is said to be defined when it gets space. Variable is said to be just declared when it don't get space, but you are saying it is going to be used in the scope, and that only possibility with the declaration of variable is extern. Now some may think that suppose that is about the extension of the scope. One clarity here I want to give because there is some confusion. Suppose if I take a file here, I'm taking a file. There is only one file. Suppose there is test.c. There is only one file I'm using. Now, if I say extern here, extern int, suppose z, if I write like this, now because there is only one file and what it does is it will try to search z for the variable z in the entire program. Because there is only one file, it does not find, it will give error if I don't have z somewhere. Now sometimes what happens is I can write int z equals to 0. In this case, when I initialize this, then what compiler does is it will just ignore extern. It will just ignore extern. So because now it is ignoring extern, so this is a definition. So if I initialize a variable with 0, so initialization is not definition. The important to remember is initialization is not definition. Memory allotment is definition. So without initialization, memory is allotted. But here extern int z, if I write extern int z equals to 0, suppose if I don't write equals to 0, then it will search for z, and if it is not found, it gives error. Suppose if I write extern int z equals to 0, compiler ignores extern. It will ignore extern. So when I don't have extern, memory is allotted. So it is definition. Remember that initialization is not definition. Initialization does not allot memory, but initialization makes the compiler, forces the compiler to extend allot memory, but uh, initialization is not definition. Only when memory is allotted, it is definition. No memory is allotted, it is declaration. Okay, this is one thing related with global variables. Then we'll see static variables. Then in the next session, I'll solve some programs because I want to cover static variables. So when you take static variable here, the static variables, as I told you, there are two types of variables, local and global. When you declare a static, a variable with keyword static inside the function, inside a function, static with static, then it is local static. If I declare outside a function, outside all functions, keyword static. So it is global static. So if I declare a inside a variable with keyword static inside a function, it is local static. If I declare a variable with keyword static outside the function, it is global static. So when you take local static variable, the scope is same as, so if you take static variable, the scope is same as auto variable. And global static variable, if I take, the scope is same as global variable. And when I take lifetime, so when I take the lifetime of here the variables, so this is one table I am giving. So the lifetime of the local static variable, it is entire program like global variable. And global static variable, global variable. So lifetime of static variable, whether it is local or global, it is entire program global. That's what I told you in the beginning, that they'll get space in the memory before execution of the program. So they will be there live in the memory till the end of the execution. So the lifetime is the entire program like global variables. So if they are declared inside the function, scope is limited to that function, but they are available in the entire program during the entire execution of the program. If they are declared with the global, with the outside the function with the keyword static, they are global static variables. The scope is like global variables, means entire program, and they are available during the entire course of execution of the program. Now the difference, only difference, now if I take global variable, now global variable and versus global static variable. So there may be a confusion here, global variable and global static variable. The only difference is this scope can be extended with the extend keyword. Its scope can be extended with extend keyword. Now this is fixed. Scope is fixed file scope. I cannot extend the global static variable. So it is fixed, cannot cannot apply, can't apply extend for this. So otherwise global and global static are same. Only thing is global I can apply extend and extend the scope. Global static I cannot apply the extend. So the scope of global static is only file scope. It is fixed. Are the concepts I want to give you before I solve the programs. I think now we can stop here because I want to give a lecture for